My name is Sarah Elliott. I'm the Director of Programs here at the Stone Barn Center for Food and Agriculture. I'm thrilled to see everybody here tonight for the third lecture in our three-part lecture series this summer, focused on the intersection of food, agriculture, and climate change. So why did we choose to focus on this topic here this year, climate change and agriculture? So, as a society, we've come to think of our agricultural systems as a given, with mostly negative externalities. It's damaging to the environment, it produces unhealthy food, and there's too much waste. So we all know these things, and they're true, but also, the truth is that agriculture does not have to be a contributor to environmental degradation or to climate change. In fact, smart approaches to regenerative agriculture show us that by growing food in harmony with nature, we can actually grow enough food to feed the planet without compromising the environment, without compromising animal welfare, nutrition, or human rights. We can increase biodiversity and improve water quality. We can mitigate the effects of climate change that are already upon us through adaptation, and we can actually slow and reverse climate change itself by sequestering carbon in healthy soil. Good news. So here to tell us how food and agriculture can do all of that is tonight's speaker, Marcia DeLonge. Marcia is the senior scientist an agroecologist in the Food and Environment program at the Union of Concerned Scientists. Her research identifies practices that lead to healthy, sustainable food and farming systems, including viable opportunities to adapt to and mitigate climate change. Marcia is one of the leading thinkers in a promising area of research, carbon farming, using agricultural practices to store carbon in soil and plants. And her work embodies so much of the thinking and exchange that's taken place here this summer to identify ways towards a brighter food future. We're thrilled to welcome Marcia, so please join me in welcoming her here tonight to share her insights with you.
Okay, can everybody hear me okay?
Do you want this or do you want that?
Or should I use that?
It's up to you, whatever you're more comfortable with. That way you come on.
Okay, I do like to walk around a little bit. I'm a hand talker. So I wanted to just start by thanking you all for being here on one of your precious summer evenings. I really appreciate it. And I also wanted to thank Stone Barns for inviting me. This is a real honor. And I also wanted to thank Stone Barns for really helping to illustrate the beauty of what a healthy food and farm system can look like. Because for those of us that work in this space, you just heard there's a lot of challenges, right? There's a lot of things that we have to think about that can be a little bit difficult at times, and it's really important to have these examples out there that show us something tangible that we can really be striving for, so thank you. So here today I wanted to start with two photos. These photos they're photos, so they show us the past, right? But I'm showing them here today because as a scientist, what I really truly believe that these images represent two different trajectories for agriculture during a time of a changing climate. So what you're looking at on the left is a situation where there is a flood on a farm. We know that floods are going to become probably more intense and more frequent. We know that these are going to cause a lot of problems for farmers given the way that we farm today. So this is a real challenge, and this is a challenge that will affect not only farms, but farm communities, and not only farm communities, but eaters, and so that means all of us. On the other hand is another image, which is another possible outcome for farmers. And this is based on the idea that there's actually a lot of science out there that's starting to show that there's extremely exciting pathways through which agriculture can actually turn this challenge of climate change into a solution. So it's this combination of challenges and solutions that I'm looking forward to talking to you about today. But I don't want to dive in too much without showing you a little bit of context about where I come from and Originally, that would be the beautiful agricultural state of Wisconsin, where I grew up enjoying the great outdoors, where harmony between nature and farming was possible. But perhaps more relevantly and more recently, I come from the Union of Concerned Scientists. And for those of you who don't know about the Union of Concerned Scientists, just to give you a tiny bit of background, we are a science-based nonprofit advocacy organization. Our mission is really to take rigorous science and put it to work towards a healthier planet and a safer world. We have about 200 staff members. That includes PhD level scientists, economists, and engineers, as well as many other wonderful people trained in a diverse set of fields. But we also have 500,000 members. We have 20,000 person science network, which is scientists that we really engage with on a regular basis in order to achieve all of our many aspirational goals. We work on actually a lot of different topics, quite a few things, but it won't surprise you that I'm on the food and environment team, and so we're really working to develop a healthier food and farming system. We take a food systems approach, so we're thinking about how do we, with the dozen of us or so that are on my team, really transform the food system from farm to fork. And my job as a scientist is to really think about how do we translate science, how do we bring science and communicate science from the farm field all the way to the Senate floor. So it's with that very aspirational and broad perspective that I'm here today to talk to you about climate change and agriculture. So both about how climate change impacts agriculture and about how agriculture impacts climate change. But not just in the negative way, as we've been saying, but also the opportunity that this impact that agriculture can have on climate change to be a positive impact. So I'm going to get to the solutions, but I do want to talk a little bit first about the food system that we have today and the challenges that are associated with that. So I'm going to take this quick step back. And the reason why I want to take the time to do this is threefold. First, the focus today is on agriculture, but agriculture is intricately connected with the broader food system. And so whenever we're trying to think about challenges and solutions, I think we really need this holistic approach, this really holistic perspective about all the pieces that are involved. Second, in a lot of ways, climate change is actually just going to be making existing challenges created by the current food system worse. So I think it's really useful to think about what are the challenges that we have today, so that we can think about the direction that those are going. And finally, we want to be thinking about opportunities for change. So what we really want to do is understand the system that we have today so that we can think about where the best opportunities are to make it look a little bit different. So what is the system that we have today? Well, if you have spent any time traveling across the country, you probably know that the system that we have today looks a lot like this. We have a lot of monoculture farms. This means large fields dedicated primarily to one crop at a time, little to no diversity. These kinds of farms typically rely on a lot of chemical fertilizers, a lot of chemical pesticides. They oftentimes, usually, leave soil uncovered. That means unprotected for large parts of the year. So off-season, bare soils, really bad. And these systems have really been increasingly linked in science and also just in practice. We can see it to a lot of the challenges that we face today. So for one thing, these systems are particularly prone to runoff during heavy rains. And runoff is really bad. It takes away soil. You can see it here. That's a precious resource for farmers. But it also takes with that water, it takes with that soil, costly fertilizers, right? So that nitrogen and phosphorus and pesticides, the things that we need to make farms work, can leave with that same water. And so that's a problem for farmers, and that's a problem downstream. So that's one of the major causes for dead zones. Of course, that do a lot of damage to marine life, but not just that, to fisheries, for tourism, and so forth. So this is a picture of the dead zone. In a way, it looks kind of pretty, but what you're supposed to see is let's see if do I have a pointer? Yes. Okay, so this is the size of an area in the Gulf of Mexico that's suffering. Every single year, we throw tons of money at it, and it's not changing. It's about the size of Connecticut this year. So this is the kind of thing that is a problem. And the same kind of, when you have a heavy rain, the same water can not only lead to these kinds of problems, but it can lead to flooding. It can lead to flooding locally. Of course, we talked about that in the beginning, but it can also lead to flooding in communities downstream. And this is, and we'll talk about this a little bit later, but related to the way that we farm. Now, I was talking about too much water in one place at one time, but an equal problem, which is happening even in some places in the same spot in a short time frame, is too little water. Too little water when you need it. So this, of course, has impacts on yields and farm profits, so that's not good. Some places have water resources, and they're able to kind of mask the effects of drought from time to time. But what's important to realize here is that in many cases, we're actually draining our really critical water resources. So we're pulling water up out of the ground, everything looks great above ground, but in the long run, we might have a problem. In fact, we're pretty much guaranteed to have a problem, and we know that from history. This is a lesson that we should have learned. This is a picture from the Dust Bowl. Here you can see, so this was in the 1930s, you can see a farmer here whose hand is showing right now where his wheat should have been at this time of year. Okay, so this is a really, really serious problem. We're talking about farmers and farm communities that are devastated, millions of acres of land that have to be abandoned. And this was from a perfect storm of a combination of policies and pushing the land too far, and also bad weather that led to this kind of a problem. And it was in this context that President Franklin D. Roosevelt said, the nation that destroys its soils destroys itself. Many of us have probably heard that wonderful quote. And I think those are really important words that we should take to heart. And yet, despite this history, we are today still facing a landscape that's actually shifting in many ways that are very concerning. So we're losing millions of acres of grasslands across the plains that are being converted to croplands, and at the same time, farmland as well is disappearing, decreasing overall. And both of these trends have been connected both to soil, both to problems with soil, but also to significant losses of biodiversity, including losses of key pollinators. Okay, but what does it leave behind? So what we have left, and I mentioned this in the beginning, of course, is these monocultures, which do provide us with a lot, but when we think about all of the problems that we're seeing on the landscape that increasingly are linked to this kind of farming system, we want to think really carefully about what are we getting out of these kinds of farms, because it is something, but again, in this mindset of like, we're trying to figure out what we can change. So what are we getting from this? And it's important to realize that we're not getting a whole lot of food out of the way that we farm today. About a third of our corn crop, so I should say farmers planted and harvested 82.7 million acres of corn in 2017. So that's a lot. About a third of that went to animal feed, about a third of that went to ethanol and fuel and related products, and the remainder was split between exports and stocks and food ingredients, but when I say food ingredients, I mean things like corn syrup. So, of course, we have more than corn out on the landscape, but the pattern holds true that from a lot of the acres that we have out there, we're not producing a whole lot of food that creates the healthy diets that we need. So only actually 2% of our farmland is used for fruits and vegetables. This can feel a little alarming when you think about the fact that the USDA actually recommends that we have 50% of our plates filled with fruits and vegetables. And I will say that we don't actually need to have 50% of our farms in fruits and vegetables, thank goodness. But just realizing that, that we have a system that has some opportunity for change. And another thing to think about in this context is that we waste 40% of the food that we produce. I think this is was a topic of another lecture here. And so when we think about the opportunities to be to be shifting the way that we're doing things, the way that we're producing things. There's just a lot of room for growth. And back on this idea of what is the food system actually that we have today actually getting us, it's really ripe for change. It's really ripe for change because we have a serious problem in this country with adults who are suffering from dietary diseases and also an alarming amount of food insecurity, considering how good of a condition a lot of people are in this country when it comes to the food system. And I'm just scratching the surface here, but I just wanted to touch on one of the more another social piece of the problems of the food system, and that's that it's not just eaters, but it is laborers who are suffering from the food system that we have today. And all of this to say, there is so much room for improvement, right? So when we're thinking about opportunities for change, they have got to be there. Okay, so with all of this said, what are the changes? What are the impacts that climate change actually is going to have on agriculture? And here's where you're going to see why I spent so much time setting this up, because this is going to go a little bit faster because these are all really closely related to the problems that we have today. So, more extreme rain events are expected with climate change, and more extreme rain events are expected to bring more runoff, more dead zones, more droughts, more floods. Well, more droughts and more floods on farms and in downstream communities. And more droughts are expected, more climate change is expected to bring more droughts, and those droughts, of course, will lead to more yield problems, will increase risks of fires on both farms and ranches, will lead to this problem of increasing our risks for our long-term water supplies, and also all of the social concerns that come along with that. And climate change is expected to bring more heat, and more heat is going to be causing problems for farm laborers and for animals, of course. Okay, and just a couple more quick things, but we're also learning in science that changing carbon dioxide levels in the atmosphere, which are, of course, driving climate change, are also potentially changing the nutritional level of our crops. So this is a big problem that we need to be thinking about too, and this is true for wheat and rice and soy, a lot of our staples and other things. So for just recognizing that there's a lot at stake here. Okay, but let's start getting to the solutions, because that's what's really important. And here, let's talk about agriculture's impacts on climate change and the solutions. But we first need to just talk a little bit about the landscape in which agriculture can be a solution for climate change. So we need to think about climate change as a whole. So the bottom line that's happening with climate change today is that we just have too many emissions, and we have too few sinks. So we have too many emissions of carbon dioxide and other greenhouse gases. We have too many emissions from land use change, from deforestation, and we really need to be building more carbon in our soils, and we're not doing that. So just to quickly show you a figure from a paper that has come out in the last year that's trying to describe this problem. Here we are around now, pretty close to 2020. We're emitting about 40 gigatons of carbon dioxide per hectare per year, an additional 5 from land use change, and we're not really doing much on the sink category. But we know that we need to reduce these emissions and increase things fast. Okay, so 2030, we need to be really changing the picture. And agriculture has a huge role to play here. Agriculture has a huge role for two different reasons. First of all, climate change, agriculture is actually contributing directly to climate change itself. So in the US, agriculture contributes about 10% of all climate change emissions directly. So this is things like nitrous oxide emissions from soils, also manure management, and methane from cattle. And when you look globally, there's a similar amount of direct emissions, but we also see emissions associated with deforestation, which are linked to agriculture. And when you take a broader scope and you think about the whole food system, as we've been talking about, that can look even bigger. And while this might seem like a problem, these are leverage points. These are places where agriculture, there's opportunities to really bring these numbers down and really help contribute directly to the climate change problem. But here is where it starts getting really exciting, because the other way in which agriculture can start to help with climate change is by actually sequestering carbon in soils. So this actually has to do with some basic plant and soil biology, right? And so I just want to walk through that really quickly. So how this works is that plants take in carbon dioxide as well as water and nutrients from the soil like nitrogen and phosphorus, and they combine this with sunlight in order to produce the sugars and starches that create roots, that help grow roots below ground, and the foods that we all eat above ground. Oh, and I should say before this that they're doing this with a lot of help from the microbial community. So there's a lot of microflora and fauna that are working in that soil to help make that possible. And that's a really exciting place in science right now where there's a lot of new discoveries being made. But what happens is that when you have a less healthy soil, instead of this natural balance cycle that's kind of keeping itself stable over time, we have a situation where soils are oftentimes losing more carbon than they're gaining, losing more water than they're bringing in, and losing more nutrients, more nitrogen and phosphorus and carbon being lost. So carbon being lost, not good for soil, and nitrogen and phosphorus, remembering those pictures of the dead zone and the runoff and so on. So this is not a picture that we want. And then the other problem here is that if you have an unhealthy soil, then you also have a situation where you need to add more in order to make it work. And so this is where we see more chemicals being added, more fuel being used, and those, of course, are additional greenhouse gas emissions. And I want to just quickly say that for climate mitigation, it's not just what you build in soil carbon that matters, but you also have to be able to do that in a way that doesn't add additional emissions. And so you really need you need to have more carbon than you have emissions of some of these other gases. So we need to be thinking about all of those pieces fitting together. Okay, so we know that the photosynthesis and the way that plants work and the biology can work in our favor. If we do it right, we can get more carbon into soils than we lose, and we can do it in a way that reduces pollution and also is working well with the water cycle. And so that's exciting, maybe in a little bit of a way, but how significant is this, is the next question that comes to mind. And here's where I just want to give you a little bit of an example to show that this is a powerful effect. Biology is a very powerful effect for moving carbon around in the carbon cycle. And so here you're looking at an image from NASA that is the top one is in the spring and the bottom one is at the end of summer, and you can see that those bright red areas are where there's a lot of carbon dioxide. And so then you can see that the carbon dioxide goes away towards the end of the summer during the spring, and that's because the trees have sucked it all up. This is spring in the summer in the northern hemisphere. So you can see that this is a detectable, important process where we can see actually carbon moving around within the system. And that was one way to look at it, but you can also see it in our classic figure from Mauna Loa of showing CO2 rising in the atmosphere, and that average line is the black one, but the little wiggles, the red, that's actually the seasonal fluctuation again. So you can see the power of plants even within the climate change signal. Okay, but that was about plants and that was about atmosphere. So what about soil? So soil actually holds way more carbon than both plants and atmosphere combined. So here's just a little bit of figure showing how much, with the brown area is how much carbon, relatively speaking, is in soil versus in trees and in the atmosphere, and you can see it's much bigger. And you should realize, since we're talking about science and the carbon cycle, that it's not the biggest pool. Actually, oceans hold a lot more carbon than soil, and fossil fuels still have more as well, more and quite a bit as well. But with soil, we have 1,500 billion tons of soil organic carbon. So that's a lot of carbon that we have to work with. Now, realize that this carbon is spread all over the world and that it varies. It varies over space. So you can just see the variability in the colors here, and there's a lot of factors that drive the variability. The reason why some areas have more carbon and some areas have less have to do with climate, they have to do with biology, they have to do with elevation and time and disturbance. But back to the key point here, they also have a lot to do with management. So management matters. All right, so if management matters, then what are actually the kinds of practices? What does this look like? How do we get more carbon in soils from this big picture carbon cycle perspective? And I want to walk you through a few, but they all kind of follow the same principles. So they all kind of follow these principles of we need to keep soils covered, we need to keep them protected. We want to maintain living roots, those roots that help pull carbon dioxide out of the soil, out of the atmosphere and into the soil are so important. We need to minimize disturbance because we want to make sure that once carbon is in the soil, it stays there. And we want to add diversity. So one of the practices that has shown to work for farmers and that scientists have found to also be very effective is cover crops. So just keeping soils covered during the whole season, even when the major crop isn't growing. And so here you can see just a boundary between an area where there is a cover crop and there isn't. This would be during the off season, so it's nice and green. And that's what we want to see. But keep in mind that cover crops can be used over very vast areas. And cover crops could also be used, say you only have enough money or time to put cover crops in some areas, you can put them in places that are really strategic. So this is in the Chesapeake Bay, and you can see cover crops all around the edge because not only do these sequester carbon, but they suck up nutrients. So they're protecting the Chesapeake Bay from some of those problems that I was talking about earlier. No-till, especially, so farming without plowing, right? And so this is about no disturbance. This is about reducing the disturbance in the soil. And so when no-till is used, especially with cover crops, it can be very effective in building carbon-rich soils. So that's another practice that, in many cases, is being shown to potentially increase soil carbon. Here's another one. This is crop rotations. Now we're talking about increasing crop diversity. And this is really important because different crops give and take different things from the soil at different times. So some crops require more nitrogen and some actually help get it into the soil. Some have deeper roots and help to build carbon, whereas others have less deep roots but maybe are more profitable. So crop rotations can really help farmers balance those needs between the longer term benefits that can come from some crops and also the need for some of those shorter term high profit crops, which of course is a critical piece of the conversation. Now another thing about, so you can design crop rotations in ways that actually really boost soil carbon, also ways that can reduce the need for fertilizer. Again, thinking that big picture perspective about reducing emissions, that's an important piece. And they break up pest cycles. So by moving crops around, you can actually break up pest cycles that typically occur, which means less pesticides, less chemical use, and so on. Crop rotations can take a lot of different forms. So that was just a 3-crop rotation, but we can think about crop rotations that are much more complex. Of course, that adds complexity for management, but in cases where it works, this means that we can think about adding potentially even more richly carbon storing crops or trees, so things that can really boost the effectiveness of certain aspects of the system that you're trying to create. Now, those were all about cropping systems. There's also a lot of ways to manage rangeland systems or grazing land systems that can help build soil carbon. So we know that grazing lands, when they're managed or when they're not really managed, can be very damaging to land and can reduce carbon stocks in soils, but it doesn't have to be that way. So when we make sure the animals are in the right place in the right time, these systems can be shown to sequester a lot of carbon. And many soils are really much better suited, or many areas of the country are much better suited for grasslands and croplands. Grasslands bring a lot of important diversity. They're really important for reducing nutrient pollution. And so if we can find ways to manage them in ways that work well, then that can be bringing a variety of different benefits. And while I'm talking about the benefits of different kinds of lands and how we might mix them together, it's worth realizing that there can be a lot of benefits from reintegrating crops and livestock and potentially in very novel ways. So we can think about bringing together crops and livestock, as well as potentially bringing in agroforestry systems, or what's called silvopasture systems, where we're getting more trees in those systems as well. And this can solve a lot of different problems, because right now, lots of times crops and animals are very far apart, and this means that crop producers and animal producers have different problems, opposite problems. You have a lot of crop producers need fertilizer, and they don't have it, so they have to buy it, whereas animal producers have a whole lot of manure, and they don't have anywhere to put it. Likewise, the situation with feed, crop producers have all the feed, and in many cases when animals are being raised separately, then of course they need to buy their feed. So thinking about bringing these systems back together, in many ways they used to be this way, but doing it in really innovative and creative ways that helps protect both grasslands and forests can be great. So something to think about there. Okay, so there's a lot of different examples there for you, but what actually is the potential? How much carbon are we actually storing by using these kinds of practices? This is the next thing to think about. So I just wanted to show you a few, I guess, pieces from the science literature, my favorite weekend reading. Scientists are showing that on average, things like no-till and cover crops and crop rotations can lead to sequestration rates of about 0.3 to 0.5 megagrams of carbon per hectare per year, which is significant. These are positive rates of carbon sequestration. Similarly, grazing management and adding perennials, so that means those long-lived, deep-rooted plants, including agroforestry or forestry systems, in many cases can lead to possibly a little bit lower, but in many cases quite high rates of carbon sequestration as well. And forest land as well, so whenever we can get trees into systems, then that can help with soil carbon sequestration. Keeping in mind that forests also bring more carbon above ground too. But here we want to talk about the stability of soil carbon. So there's actually a lot of other different practices that I haven't really talked about that can also help to sequester carbon. These are things like completely setting land aside. So that means not using it for management, but letting it grow and restore itself, or managing water in more creative ways to help build those, grow more roots and build more biomass. Restoring degraded lands can be really important. If we think about areas where that you can't grow anything, if we think about what can we do in order to bring those places back to life. Rice management is really important, and restoring histosols, those are peat lands. But these have different kinds of scalability. And so that's why I want to show you here really quickly this figure, just to think a little bit about what our options are to work with, and the opportunities we have for more and less scalable solutions with lower and higher rates of carbon sequestration, and therefore benefit for the climate. So this was a figure. This is adapted from an important paper that came out that reviewed all of the literature last year. And it showed that, so here we have area. This is scalability, so where you could potentially bring these practices to life, and then the rate of carbon sequestration that's possible here. So how much carbon can these practices actually pull into the atmosphere? And what you can see is that the ones that we were just talking about now, managing grazing lands, managing cropping lands, and then things associated with that, like biochar is something that's oftentimes thought of within these kinds of systems, as well as roots. How can we just focus on roots and think about how to make roots more effective at storing carbon, within any kind of plant? So these are all situations where we have modest sequestration over a large area. So we can scale these things up, and a little bit goes a long way. We also have a bunch of practices that maybe have much higher rates of carbon sequestration. Maybe you can get twice or more the amount of carbon per acre, but they're less scalable. So things like degraded working on building up these degraded lands or working on rice systems or peatlands is a really big one where you can be very effective, but you have less area to work with. And then there's places that are more modest rates and they're less scalable. But these matter too, because with the size of the problem that we have, we really need to be thinking not about a silver bullet solution, but about all of the pieces of the puzzle that we can bring together in order to solve this problem. So again, this is those things like the set-asides and managing water and so on. And these aren't perfect numbers, these aren't perfect bubbles. There's still a lot of research going on in all of these areas, but it just gives you a little bit of a sense for the kinds of things that we have to work with. And the good news, when we think about how we're going to pull all these pieces together and actually make something happen that matters, is that we have a lot of land to work with. Across the globe, the number of acres that we have available of grazing land and forestry land and cropland are huge. Most of the land that we have on this planet is land that's managed, and so we can be leveraging all of that land in order to bring up these solutions. We have a lot of area we can scale up these practices on, and then I also just wanted to say we don't need to just be thinking about the global scale. We can be thinking on a watershed scale, and when we think on a watershed scale, we can be really creative about how we optimize landscapes. So you don't need to think about, do I just do grazing land management here? Do I just do crop rotations? We can mix and match so that we can see the most benefits possible. Okay, I'm a scientist. I have to mention some of the challenges and uncertainties. And I did just mention briefly that some of the numbers are not known, but I wanted to just raise a few other points. It's hard to measure carbon. It's hard to measure changes in carbon because, like I showed you, there's a huge pool of carbon. There's a lot of carbon, and also the good news is that we only need a little change. But that also means that it's really hard to measure a little change in a big pool. So that just adds a complication to the science. Another is that we don't know those carbon sequestration rates. In many cases, they vary over space and time. So we know they're exciting, but we don't know exactly what they are. And you might have heard of carbon saturation. And this is the fact that ecosystems over time come into balance. So you might see really high rates of sequestration in the beginning, and then maybe it'll even out as that ecosystem comes into balance. That's not a bad thing. We want to be maximizing the carbon in the soil, but it's something to keep in mind when we think about the solution. And then finally is just this issue of net greenhouse gas accounting, and that's just fancy language to say we need to make sure that when we add carbon to soils, we're doing it in a way that doesn't bring unintended consequences. I want to now quickly move into just thinking about how even if we can't solve the whole climate change problem with soil carbon sequestration, there's so many benefits to these kinds of practices that they're worth doing. And it's really important that there's these other benefits to these practices because we can't just be trying to mitigate the problem. We have to be figuring out how we help farmers and ranchers adapt to the changes that are inevitably coming. And in fact, they've already started. And so just a few words about water. As I just said, we really need to be thinking about the possibility for adaptation. And because of that, a colleague of mine were really interested in trying to understand better what do we know from the science about how these practices affect water, about how they affect how fast water can move through soils, if it can move fast enough to avoid floods, if it can get deep enough in order to be available for crops, and what do we actually know about that? And this is going to be a whirlwind tour. But I just wanted to say that what we found, we did a massive literature review, a meta-analysis in science terms, and what we found is that, in fact, the same practices that we know can build carbon can also improve these really critical infiltration rates. And we wanted to know, that's like on a per acre scale, that's on a field scale. We don't know, does that matter? Does that make a difference on a landscape scale? So we did do some modeling work in Iowa. Iowa is one of these states where we have lots of land and corn and soy, so it seemed like an appropriate place to test the hypothesis. And what we actually did find is that if we moved landscapes from this monoculture kind of world that we have today, and we perennialized those, we added cover crops, we thought about bringing grasses back, that this actually could add up to make a really substantial difference. So we saw that there was 16% greater water use. That just means more water available to crops, and also 20% lower flood frequency, which means that by adopting these practices in our model, we actually made a big difference in terms of some of these huge risks that we face. All right, so just a few success stories. We know that there's potential in these kinds of practices for climate change. We know that there's potential for other benefits, including the water floods and droughts, but also nutrient pollution. There's a theme I've mentioned several times, but are people actually doing these things? So I just wanted to name a few places where people are doing these things and seeing some success. So this is an example from Iowa, the home of corn and soybeans, as I've just mentioned. And I wanted to show you this this picture, which is a picture of a really cool experiment that's happening that's led by Lisa Schulte-Moore from Iowa State University, and that farmers have been involved with as well. And in this experiment, they were trying to think about, like, could we sneak in to these corn and soy fields just a little bit of prairie? Because we know the benefits of grasses, we know that they do a lot of good. Could we just sneak in a little bit? And what they found is that by putting just 10% of prairie among these crop fields, they saw disproportionate benefits. So they saw over 90% reductions in nutrient loss, as well as major reductions in soil loss, and they also saw benefits for birds and diversity and so on. So really exciting just to think about the possibilities of all the benefits that these kinds of things can bring. In another experiment in Marsden Farm, which is also in Iowa, just down the road, and they were working on trying these crop rotations out and thinking, like, does a 3 and 4 crop rotation actually, can you be profitable on this? So they did a lot of work to see whether these systems were viable, and they found out that yes, they were, and that they brought a lot of environmental benefits. It's not all in Iowa. This is a picture from Montana. This is Dave Oyen, whose story was chronicled in a really wonderful book called Lentil Underground. And what you need to know about Dave Oyen is that he was on a mission several decades ago to save his family farm. Soils were degraded, there was a 3-year drought, there were low grain prices and high fertilizer prices, and so he strayed from the normal wheat and barley that was being grown and causing a lot of these problems, and integrated lentils, which is a legume, into multi-crop rotations. And not only did he save the family farm, but he started a business, which is Timeless Natural Foods, which is now $1 million enterprise. And last but not least, this is a project that I actually worked on for a while, so it's dear to my heart. It was called the Marin Carbon Project, and it's located in California. And what happened here is that there were farmers and landowners and scientists at UC Berkeley, led by Wendy Silver, who were trying to ask, like, what could we do for grasslands, since they make up so much of a part of the state, that could help with the climate change solution. And what I want to share is that the whole point was trying to add compost, but compost made out of waste materials, which is really important, and to see if that could boost the productivity of the land and build carbon and do good things. And even the cows saw the outcomes of the experiment were positive. This is the blue boxes here show the outlines of the field plots that had compost, whereas the other ones did not, and the cows actually found those areas, which we thought was pretty neat. So to wrap up, if we want to move away from the farming system that we have today to something a little bit more diverse, we can do it. But there are going to be obstacles, there are going to be barriers that we need to overcome. I just want to name a few really fast. Many of us know about this yield gap, this issue that in organic systems or other sustainable systems, sometimes the yields are lower than in the systems, lower than in the conventional systems. But I want to just point out that this is a result of many decades of really high investments in those other systems. And so we can change this, we can shrink this yield gap. We just need to do the research. We need to do the research, we need the crop varieties, we need tools that are actually devoted to these new kinds of systems. And we need training. We need to make sure that when we find something out in the lab, that we can bring that to the people who can implement it. Another problem, of course, is economic markets. I've talked a little bit of that today. We know we need to have creativity and entrepreneurship here, but we can also do things with farmers markets and food hubs. We can do things with procurement policies. There's exciting work going on to help make sure that there's markets for food coming from the systems that we want to see. Another lever, of course, is diets. It's related to markets and all of these things. And of course, this is something that we want to think about. Many of us can benefit from better diets, but I hope what I've convinced you of today is that we can also benefit from just looking at other sources, getting food from land that's managed in a better way. And we really improve our degrees of freedom if we deal with this food waste problem. So if we deal with this food waste problem, we have a lot more land to work with. Last but not least, I come from DC. Policy is a lever. It feels like a lever that doesn't budge much sometimes, but it does slowly over time. Right now, the Farm Bill is going on or not going on, depending on how you look at it. But policy is important, but policy really needs voices. So we've been working with the Heal Food Alliance and many others to try to make sure that we're voicing to people, decision makers, the changes that we think we need to see. And over time, we really believe that this can make a difference. Luckily, we don't have to rely all on federal policy. There's great state-level policies that are happening. 8 states have traction, including New York, on healthy soils policies. And we also have international momentum. Things like the French 4 per meal campaign, which you might have heard about, which is about healthy soils, and also the UN Sustainable Development Goals are really making great strides towards making a better environment for carbon farming and healthier soils possible. And that's it. So I really think that we do have a long way to go. We have a lot of work to do, but we have a lot to work with. And I think that's good news. So that's all. Thank you.